Assalamu alaikum students. Today I'm going to revise with you the mensuration concept, which is very important concept in IGCSE mathematics. I have selected uh, paper 2 questions, and if you will solve these paper 2 questions, then I think you guys can have complete understanding when we will use them in paper 4, because in paper 4 you know that he can mix question of mensuration with different type of figures, but here you will see how to apply the mensuration concept to the specific figures. So I have divided the mensuration paper 2 worksheet into mainly three sections. The first section is on sectors and arc lengths. So maybe in this video I will cover sectors and arc lengths, and later on in the next video I will do the rest of this worksheet. So let's start. Question number one is related to a figure, and that figure is made up of a rectangle and a sector. For example, what is this? This is a rectangle, and this one is the shaded part is the area between the two sectors. So area between the two sectors. So this question is a mixture of rectangle and sectors. So let's revise first the what is the area of a rectangle. Rectangle is a 2D shape. It has length, it has width. So the area is length into width, and the perimeter is length plus width plus length plus width. So the perimeter is length plus width plus length plus width, or some people write it as 2L plus 2W, or some people take two common, L plus W. So in rectangle, the most important thing is when we join the opposite corners, that is called diagonal. To find sometimes we want to find a diagonal by using the Pythagoras. Suppose I have a rectangle. This is 4 and this is 3, and I want to find the length of the diagonal. So the length of the diagonal is a big square root. The sum of the squares of the two shortest sides, we can easily find the diagonal. But sometimes in the exam, he gives you the diagonal and he wants you to find one of the unknown length. Then x is equals to 5 squared minus 4 squared. It's again a Pythagoras theorem, and then you guys can easily get the required information. Any rectangle can be used in mensuration when we want to find the area and perimeter, or sometimes in trigonometry he engages, the Pythagoras theorem inside it, right, guys? And if you see that there is an angle here, and in angle we can also use trigonometric ratios, but I think these type of things I will discuss with you in the trigonometry worksheet. So let me erase this thing. So rectangle is explained, the background of rectangle is done. Next is sector. So be careful, guys. You all know that this is a circle, and when the circle is divided into this shape, this is the radius, this is also the radius, and this is the arc. So the area bounded by the two radii of the same circle and the arc, it is called a, a sector. So this is called a sector, and this is also a sector. This is a major sector, and this is the minor sector. So minor sector plus major sector is a complete circle. For the circles sector wise, you need to know the central angle, and if you know the central angle, it is to be divided by 360 degree, because we need to compare it with total angle in a circle. The total angle in a circle is 360. If you want to find the area of a circle, you need to know the radius of the circle. So here you will multiply with pi r square, which you already know that area of a circle is pi r squared. And this whole thing is called area of a sector. So area of a sector, if he gives you this angle 30 degrees and the radius is 5 centimeters and I want to find the area, so the area is equal to 30 degrees divided by 360 times pi times 5 square. So whatever the answer comes, that will be the area of this sector. Second thing which is important and related to the sector, that is the arc length. Yani only this length. So if examiner wants you to find the arc length, idea is same. This angle is x, so we write x over 360. But this time, don't multiply with the area of a circle. You need to multiply with the circumference of a circle. What is the circumference of a circle? The perimeter of a circle, or the outer boundary length of a circle, is called circumference. So the circumference is equal to 2 pi r. So you saw, guys, in the area of a sector, we multiplied the ratio of the x to 360 with pi r square, but in the case of arc length, we multiplied with pi r, 2 pi r, sorry. So we talked about arc length and the area of a sector. Moreover, we also see what is the area of a circle, which is pi r square, and the area of circumference of a circle is 2 pi r. One thing which I don't want to forget before I start with the questions, sometimes the examiner asks you perimeter of this shape. So perimeter of this shape is made up of, yani perimeter, the terminology of perimeter is used when we want to find the length of the, sides or arcs which are actually bounding the shape. So this shape is bounded by radius, and arc. So if you want to find the perimeter, r plus arc, for example, r is 5 and this angle is 30 degree. So how will I find the perimeter of this shape? The perimeter of this shape is 5 plus 5 plus 30 over 360 times 2 times pi times 5. And then we can easily calculate the perimeter of the shape. So the background information related to arc lengths and sectors has been given. So now, without any further delay, we can carry on with the questions. So let's read the question first. The diagram shows the cross section of part of a park bench. So this is like a bench shape. It is made up of a rectangle, length 32 and width is 8 centimeter, and a curved section. The curved section is made up of two concentric. Concentric mean those two circles. And which circle he's talking about? This circle and this circle. They have the same center. So we say that the two circles have the same center. They are concentric. They have the same center. Both circles are making 125 degrees at the center. The inner radius is given by him as 40 centimeters and the outer radius is 48 centimeters. Yani the bigger circle here, the radius is 48 and the inner one, smaller one, has 40 centimeters. After reading this all statement, now I want to go to the to find the area of the shaded portion. So to find the area of the shaded portion, first I will concentrate on the area of a rectangle, which is very, very easy because area of a rectangle is length into width. So area of a rectangle is length into width. What is the length? 32, and that is 8. That's pretty simple. Next thing is I want to find the area which is a common area, not the common area, the shaded area, which I'm going to shade it with green. That area has to be found. This is pretty simple. If the bigger area, a smaller area is subtracted from the bigger area, we can find this shaded area. So the big area minus the small area. So big area, the sector is 125 over 360 times pi. The radius is 48 square. And the small one is same central angle, 125 divided by 360 times pi times 40 square. So an outline has been drawn for this question. I'm ready to start. Let me start. The shaded area, it is equals to rectangle plus, so the area between the two sectors. Okay, so rectangle, and we can write it as a sector area. This is just identification that what we are talking about. So rectangle is basically length into width. We saw that 32 times 8. Next, sector area was 125 360 times pi times 48 squared minus 125 over 360 times pi times 40 squared. Now the job of a calculator starts because we have written the full expression. 30 32 times 8, area of a rectangle, plus 125 over 360 times pi times radius square is 48 squared minus 125 over 360 times pi times 40 squared. So once you write everything in the calculator, we are ready to find the final answer, which is 103.9. So 103 1023.9. This answer is coming in centimeter square form. So what is the requirement? Calculate the area of the, correct to the nearest square centimeter. So nearest square centimeter. So after we want to write the answer 1023, any to the nearest square centimeter, what is after 3? So after 3 is 4. So we have to write 1024 centimeter square. So this number, this answer is written correct to the nearest centimeter squares. So in the exam, you have to write 1024 centimeter square. At this time, examiner has restricted you to write your answer to the nearest whole number or to the nearest centimeter squared. But if a student writes here three significant figures, that will be, considered not the accuracy marks the student can get. So the examiner will give him just 4 marks. So please be careful. Look at the last instruction from the examiner that he needs the answer to the nearest square centimeter. So that has to be 1024, not 1020, because some students, they will be thinking we have to write, as in the beginning the examiner said, we have to write always the answer to the three significant figures. So that has to be written. No, here the examiner said you need to write your answer to the nearest square centimeters. Anyways, we are done with that question. So here we want what? He has provided us the shaded part, and that shaded part is between the triangle and a sector. Did I talk about the area of a triangle? Guys, triangle has two formulas for area. One is a very famous half times base times height. For example, if I give you a triangle and I give you the height, okay, and the base, you can write half time base times height. Another trigonometry formula is if you know the two sides and the included angle, you can write the area of a triangle as half times the product of the two sides which have the common vertex, okay, the common point, and the angle between these two. You have to take the sine of that. So these two formulas are important in IGCSE to find the area of a triangle. Now let's come back to the question. In the question, he says radius is given. Uh, he has left one unknown in the area of a segment. This is, guys, this portion is called segment. Why? Because any area which is enclosed between the chord and and an arc length, that is called a segment. So area, how do we write the segment? So segment area is equals to sector minus triangle. I hope everyone got the idea. And this part is equal to the big sector minus this triangle. And this triangle has to be subtracted. If someone asks you your your sector is equal to what? Triangle plus segment. The shaded segment. Segment plus triangle is equal to the sector. So if you want to find the segment, what is the formula you write? Segment is equal to sector minus triangle. Area of a sector, the area of a segment is k pi minus c. We don't know what is c, what is k, but the sector area we know what is that. Sector area is 30 divided by 360 times pi times the radius is 6 squared. Next, minus minus triangle is half times, apply the trigonometry formula of area of a triangle, half times the product of the two sides which have common vertex, which is O, times angle at O is 30 degrees. So let's try, boys, to find this answer from a calculator. 30 over 360 times pi times 6 squared minus half times 6 times 6 times sine 30, right? Be careful, guys, your calculator has to be in degree mod, because I was using radian mod before, so I converted into degree. Now we are ready to get the answer. The calculator is giving me the answers not in terms of pi, so it means I need to solve them separately. So the first term is 30 over 360 times pi times 6 squared. This gives me 3 pi. I'll tell you what is the reason behind not solving the, writing the complete expression into the calculator, because that expression gives me the answer in decimals, and I'm seeing that I want to get my answers in this form. So whatever would be the coefficient of k, coefficient of pi, that will be considered as k. So here you see when I solved the first part in a calculator, it gave me 3 pi. So 3 will be my k. So 3 is my k and pi is pi. Now try to simplify the second part. The second part from the calculator is half half times 6 times sine 30. Let's get it. It's 9. So imagine, boys, if you compare, your segment area is k pi minus c, and I found out it is equals to 3 pi minus 9. So 9 is basically my C. Next question, area of the shaded region. This region, again, if you see, it is an equilateral triangle. So if it is equilateral triangle, everyone knows about equilateral triangles. All angles are same. This is a regular polygon of three sides, and interior angles are 60 degrees. So may I say this is 60 degrees? The total side is 10, 10. He needs to tell us M divides AC in what ratio? Oh, M is the midpoint. So this is 5 and this is 5. 5 and 5. Now to find the shaded area, so shaded area is equal to triangle ABC minus sector. What is the triangle area? Half times. I'm going to use these two arms. You need to do these two sides, which are 10 and 10. And what is the angle inside it? 60 degrees. So half times 10 times 10 times sine of 60 minus the sector. This sector I'm talking about is minus the sector. Formula for the sector is central angle is 60 divided by 360 times pi times. Now the radius is not 10, it's 5 square. Write this expression in a calculator. So after writing this complete expression in the calculator, we are ready to get our answer 30.2, because he didn't restrict us to write in how much degree of accuracy. So in the end, we will try to write it to the three significant figures, since there is no restriction on the accuracy. 30.2, we have written our answer to the three significant figures. Next question, he said that you need to find the area of a sector. The angle is 72, the radius is 6. Um, is he talking about area? No, he's talking about perimeter. Didn't I say perimeter is this plus this and plus this? So perimeter is made up of two sides and one arc. Radius plus arc. And you remember what is this arc length? It is 72 divided by 360 times with pi r square, well, 2 pi r multiplied with 2 pi r, the circumference. Yes. So 6 plus 6 plus 72 over 360 times 2 times pi times 6, and then you can get the final answer. But be careful, we want to get the answer in terms of pi. And in our last question, when we tried to write the full expression in the calculator, it gave us answer in what do you call in decimal form. So it's better to solve this one separately. So 6 plus 6 gives you 12, and this one you solve it, compute its value separately. So 72 over 360 times 2 times pi times 6. So when we solve it, our calculator will give us answer in terms of pi. So 12 over 5 pi. So imagine what is the constant which is without pi, that is 12. He said it is p. So p is 12. And which number is written besides pi? That is 12 over 5. So it has to be q. So 12 over 5. I hope it clears. Next, we want to find the area of a sector. Yeah, this is pretty simple question. 60 divided by 360 times pi times radius squared, 7.5 squared. So you can easily get your answer. Next, we want to find AP. So AP is this side, right, guys? So as he mentions that OAB is a sector of a circle. So OAB is a sector of a circle. So can I say that OB is 8, so OA is also 8? Didn't I mention that trigonometric ratios will be very, very important for you in this case? So now I need to find OP. Now, OP can be found out by, look, this is B, this is P, and this is O. The guy give you 30 degree and this is 8. So OP can be found out by using trigonometric ratios. So what is given to me? The hypotenuse is given to me. So if hypotenuse is given to me and I want to find the adjacent, so kah will be used. You remember the triangle which I have taught you? Kah. So I want what? I want adjacent. So adjacent is cosine of 30 degrees, cosine of 30 degree times with hypotenuse, which is 8. So I'm writing it here, 8 cosine 30. But what is my question? My question is AP. So AP is basically OA minus the radius of the sector minus OP. So radius was 8, complete radius was 8, and I have been given this information, which is 8 cosine 30. When we subtract them, we will get the length of AP. 8 minus 8 cosine of 30. It gives us answer in a third form, but we want to get the answer in three significant figure, 1.07. 1.07 to the three significant figures. Now, I want to find the shaded area APB. Let me erase everything now. I want to find the shaded area. To find the shaded area, boys, shaded area, I need the area of a sector, and from the sector, I need to subtract the area of a triangle. To find the area of this triangle, just now you have found out that this is 8 cosine 30. Why not we can use this side and the common angle, which is 30 degree, to find the area of this triangle. So the area of this triangle is half times 8 times 8 cosine 30 times sine of 30 degrees, which is the area of this triangle. If a student says, no, I don't want to use this formula because it's a right angle triangle, so I need to use half time base times height, I have no problem. You can find AP, which is 8 sine of 30. Then you can write half times base times height. But as I have already explained you the concept and of the trigonometry area of a triangle, why not? We can use this. We need not to go and find one more extra thing, but this extra thing might be used if he asks us to find the perimeter, because this is 8 sine 30. Do we need it? I don't think so. We need it because he didn't ask for the perimeter. So I'm just erasing it. Maybe at later stage we will find this type of a question where he asks you what is the perimeter of the shape. But in this case, he's asking you just the shaded area. So the shaded area, it is equals to sector minus triangle. So what is the sector, guys? Sector central angle is 30. 30 divided by 360 times pi times the radius is 8 square, and the triangle is half times One side is 8 cosine 30. Second side is 8, and the common angle is 30. So sine of 30 degrees. So then, guys, you write both of these things in your calculators and subtract them. You get your answer. Question number 7. He says, find the length of AB. Very nice. So just length of AB, length of AB. We normally show it like this: the arc length of AB, 38 divided by 360. Don't multiply with pi r square, multiply with 2 pi, and the radius is 25. And that gives you your final answer. Be careful, the examiner needs the answer to the four significant figures. Suppose if you write here 38 over 360 times 2 times pi times 2.5, you get your answer in terms of pi, but we want the answer in significant figures. It is 1.658. Four significant 1.654 SF. Next, question number 8. He said the area is k pi centimeter squared. Did he give us the angle at the center? No, he didn't give us any information, but he gives us the arc length. Beautiful question. So the arc length is 6 pi. Unfortunately, he didn't give you this angle. And he is also providing you the area of a sector. But first is, this question must have two parts. What are the two parts? In this part, I will use the arc length formula. Arc length, which is x over 360 times 2 pi, and the radius is 9. He said arc length is equal to what? 6 pi. Clear? Now use your calculation skills. Pi cancel with pi, or if you don't want to cancel pi with pi, you can send everything to the other side. So 6 pi times this 360 goes up over 2 pi times 9 is equals to x. Write everything in a calculator and see what the answer comes. Although you can cancel pi with pi, but some students, if they have a problem in canceling them, they can just copy it in the calculator. So what's the answer I'm getting? So x angle is 120. So this is 120. Now can I find the area of a sector? So area of a sector is 120 divided by 360 times pi, and the radius is 9 squares. So let's try. 120 over 360 times pi times radius squared, which is 9 squared, and it gives us the answer 27 pi. Do we need to write the answer to the three significant? The answer is no. He is writing it in terms of pi. So which number is written behind pi? That is 27. So it has to be representing k. So k is 27. Beautiful question of the day, because here we want to find the shaded portion. How do we find the shaded portion? We will find this area first, or this area. Once we find this area, we will times it with 2 to get the shaded part. So how can I find this red shaded part? The idea is same. This is equal to the sector minus triangle. Which sector I'm talking about? I'm talking about this sector and minus this triangle. So if you subtract the triangle from the sector, you will find the half shaded portion, and then once you get that area, you will times it 2. So I want to find shaded area. So two times, two times, or if you don't understand it, just show it to the examiner that I'm finding this area. So this area is sector 40 over 360 times pi, the radius is 10 squared, minus triangle, the trigonometry formula, half times 10 times 10 times sine of 40 degrees. Once you get this answer, times with the 2, that would be the area of the shaded. Uh, I will not call it shaded segment. This is the sum of two segments, one from the left and the other one from the right. If you want me, I can calculate it by putting the numbers here on a calculator display. So 2 times bracket open 40 over 360 times pi times 10 squared. Sorry, times pi times 10 squared minus area of a triangle, half times 10 times 10 times sine of 40, and then close the bracket. You get your answer 5.53. So 5.53, three significant figures. We have written our answer. Now this is area of a sector. Central angle is already given, 217 divided by 360 times pi. The radius is 6.2 squared. You can get the answer. Area of a sector. Arc length is given. Radius is given. So what I'm going to do, arc length 6.4, but it is equals to central angle is not given. So x is equals to x divided by 360 times 2 pi, and the radius is 8. Send everything to the other side to get x as a subject. So 6.4 times 360 over 2 times pi times 8. This is my x. So let us try to get x. 6.4 times 360 over 2 times pi times 8. So this gives us x equals to, don't write it to the one decimal place because in IGCSE you have to write your answers to 1 dB, but within calculations try to write it as two decimal places. So 45.84, 45.84, since I am willing to use this answer in the next stage. Area of a sector. So area of a sector, now it's easy for me because I found out the central angle, which is 45.84 degrees. So 45.84 degrees divided by 360 times pi times 8 square. Um, it's easy for us to calculate it. Next is calculate the area of a sector with radius is given and the sector angle is given. So 42 divided by 360. Can you please convert it into centimeters, because our final answer is it is in millimeters and we want to get the answer in centimeters. So 6.5 millimeter divided by 10, it should be 6.5 centimeters. So now 42 divided by 360 times 2 times pi times not pi, 2 pi r squared, it's pi r squared. I'm mixing it up. So pi r squared, the radius is 6.5 squared. So whatever the answer comes, you write it over here. Anyways, guys, next question number 13. We want this area. Did we solve this question before? Let me check it. Maybe we did it. Maybe we did it. Yes, we did this question before. So I'm skipping it. So it is already done. It is already done. Now come to this. Seems like it is also done, but let's do it again. So this is 6, and this is also 6, and this one is arc length, which is 72 divided by 360 times 2 pi, and the radius is 6. Now when I write the perimeter, 6 plus 6 plus 72 over 360 times 2 times pi times 6. So 6 plus 6 is 12. And this answer, we will put it in the calculator and see what is this coming to us. 72 over 360 times 2 times pi times 6. So it gives us 12 over 5 pi. So since we want to get the answer in this form, so P is 12 and Q is 12 over 5. Next, we want to find the shaded segment. So that shaded segment is sector 80 over 360 times pi times 12.6 squared minus triangle. This is also 12.6. So half times 12.6 times 12.6 times sine of 80 degrees. Whatever the answer comes, you write it over here. Now we come to this case. We want to find the perimeter of the shape. So perimeter of the shape is this plus this. We have to find the perimeter. It's an equilateral triangle, so it is, this is 12.4, this is 12.4, this is 12.4, this is 60 degrees, and the back angle is 360 minus 60 is 300 degrees. Now this shape is made up of two figures. Number one is triangle. It's triangle and the sector. We want to find the green area. So the green area is, let me say that it is made up of BC length and the BC arc. This BC arc. So how do we do this? First, BC straight length is 12.4, and the BC arc is, what is the central angle? The central angle is 300 divided by 360 times, not 2 pi, pi r square, it should be 2 pi. And what is the radius given to us? Radius is 12.4, and then it gives us the final answer. Next is major sector. Guys, this is major sector and this is minor sector. He said the area of the major sector is 74.5. This is 74.5. We want to find the radius of the circle. So the radius of the circle, boys, first you need to find this angle. So 360 minus 41 gives us 319. So this angle is 319. Area of the major sector, yani this sector is 74.5. 74.5, it is not 41, 31 over 319 over 360 times pi times radius squared. Send the things to the other side. 74.5 times 360 over 319 times pi, and send the square also to the other side. It becomes square root. So this will give you the final answer in three significant figures. Sectors, we want to find the shaded sectors. So the big sector minus the small sector. What is the big sector? 45 over 360 times pi. The big sector has radius 5 squared. And now come to the small sector. 45 over 360 times pi times this radius is 3 squared. Once you calculate them, you can write your answer to the three significant figure here. So we are done, guys, in this video related to sector area and arc length. Thank you. Assalamu alaikum wa rahmatullahi wa barakatuh.